You know that feeling, right? You're at the beach and you do that crazy, frantic hot foot dance across the sand to get to the water. We've all been there. But have you ever stopped to wonder why? I mean, why is the sand scorching hot like a frying pan, but the water feels so cool and refreshing? They're both getting hit by the exact same sun. Well, today we're going to solve that little physics puzzle. Okay, so to get our brains warmed up, let's start with a question right from the source material. Take a quick look at these four options. Only one of them is the correct answer to the question. Go ahead, make a guess, lock it in your mind, and we'll see if you got it right by the end. All right, to crack this puzzle, we have to start with the most important clue. Is kind of the secret ingredient that explains why different things like sand and water react to the sun so differently. And that secret is a concept called specific heat. Now, that's the official scientific definition. It's totally accurate, but yeah, it's a little dry, isn't it? Basically, it's just telling us how much energy you gotta pump into something to make it 1 degree hotter. But honestly, there's a much easier, more intuitive way to think about this. Let's just call it thermal thirst. Yeah, that's it. Imagine that some materials are just really, really thirsty for heat energy, while others, not so much. This one little idea is going to make everything else just click into place. So here's what that thirst looks like. On the left, you've got stuff with a low specific heat. Think of them as having a really low thermal thirst. A tiny sip of heat is enough for them, and their temperature just shoots up. They heat up super fast. But on the right, you've got materials with a high specific heat. They are incredibly thirsty. You have to pour tons and tons of heat energy into them just to get their temperature to budge a little bit. They heat up nice and slow. Okay, so that's piece number one of our puzzle. But a material's thirst for heat is only half the story. We also have to know how that heat actually moves from one place to another. And it turns out there are three main ways energy travels. First up, we've got conduction. This is basically heat transfer by touch. You grab the handle of a hot pan on the stove, that's conduction. The heat moves right from the metal into your hand because all the little particles are literally bumping into each other and passing that energy along the line. Then there's convection. This is how heat gets around in things that can flow, like liquids and gases. When you boil a pot of water, the water at the bottom gets hot. It expands and rises up. Then the cooler water from the top sinks down to take its place, gets heated and rises up. You get this rolling current that spreads the heat all through the pot. And last but not least, radiation. This is heat that travels as waves, just like light does. It's really special because it doesn't need any stuff to travel through. It can go right through the empty vacuum of space. It's exactly how the sun's energy gets all the way to Earth to warm up our beach day in the first place. Okay, we've got all the clues now. We know about thermal thirst, or specific heat, and we know the three ways that heat moves around. That means we are officially ready to go back and solve that puzzle from the beginning. So let's take one more look at that question. Based on everything we just talked about, which one is the right answer? Well, if you picked number one, you nailed it. A substance with a low specific heat can be easily heated. And it all comes back to that idea of thermal thirst. A low specific heat means it has a low thirst for energy. It doesn't take much heat at all to get its temperature to climb really, really quickly. And just to be clear, let's look at why the others were wrong. When something emits heat, it gets colder, not hotter. So that's out. And having a large mass has nothing to do with how easily something heats up. That's all about its specific heat. Now, you might be thinking, hey, wait, number two is a correct definition. And you're right, it is. Convection is how heat moves in a fluid. But the question asked what makes a substance itself easy to heat, which is a property of the material. And that property is specific heat. So this isn't just some random question on a quiz. This physics has a very real and sometimes, painful effect on us. So let's take what we've learned and bring it right back to where we started. So, back to the beach we go. We've got the same sun sending down the same amount of heat radiation on everything. So why in the world is there such a huge difference between the sand and the water? And here it is. This is the big aha moment. It is all about specific heat. Sand has a super low specific heat, a very low thermal thirst. It only needs a little bit of that sun energy and its temperature just skyrockets. But water has a crazy high specific heat. It is incredibly thirsty. It can soak up a massive amount of sunshine all day long, and its temperature barely changes at all. So let's just recap the big ideas real quick. The main takeaway is specific heat, which is basically how much a material fights against changing its temperature. If that resistance is low, like with sand, it heats up in a flash. If the resistance is high, like with water, it takes forever to warm up. And all that energy gets where it's going through conduction, convection, and radiation. And that's it. Puzzle's solved. But I'll leave you with one last thing to think about. This principle is absolutely everywhere. Next time you're in your kitchen, look around. Think about your pots and pans, your oven mitts, even the water you're about to boil for pasta. Which things are designed specifically because of their high or low specific heat? It's pretty cool when you start to see it. Thanks so much for tuning in.